Hello, Algebra 2. Hope everything is going okay. We are going to continue with something we started on 10.2, which is looking at how you can organize information into a two-way table and find what are called joint and marginal frequencies and use those frequencies to calculate probabilities and also then conditional probabilities. And we will then end with looking at when you don't have a table, sort of a reminder of what we did in the last session. So here we have in our initial box a two-way table showing attending or not attending a particular event. Everything that is actually entered in these boxes is called a joint frequency because it satisfies two criteria. So if you're a freshman who is attending, there are 25 of you. So it's the sort of the joining between those two categories. When you try and make totals out of like who are the total number of people attending, that would be out here. We would find our totals, and those are called your marginal frequencies. So for instance, I would have 105 people that are attending. We would have over here 76 total people that are not attending, and then we could find the total number of freshmen that were surveyed or the total number of sophomores. So anything on outside those joint boxes are going to be called your marginal frequencies. So let's first look at how we fill in this table. So we have here a school survey. Ask students whether they are attending a school concert. Of the 106 sophomores surveyed, and 42 plan on attending, of the 114 juniors, 77 plan on attending. And we want to organize these results. So we are looking at the difference between sophomores and juniors. So that's one set of categories here. And we're going to compare them against who is attending and not attending. Whoops, I went outside my box. Not attending. All right, so it told us that 106 sophomores were surveyed, and of those, 42 plan on attending. Then it told us 114 juniors were surveyed, and 77 of them plan on attending. So by filling that in, we can then figure out our marginal and the other joint frequencies. So 106 minus 42 tells me that there are going to be 64 sophomores not attending. 114 minus 77 tells me there are 37 juniors not attending. Total number that are attending when we add down would be 119. Total number not attending is 101. And that would give me a total of 220 students. And notice in both directions, this sum should be the same. So we know we did it right. Okay, now let's look at how we can find probability utilizing this table. So we want to find the probability that a sophomore plans on attending. So that's like asking the probability that you are attending given that you are a sophomore. So we're only looking at the subset of sophomores. So when we do that, we're going to look at sophomores who are attending, and that's going to be out of the total sophomores. So that would be 42 out of 106. Then we see the probability that a junior does not plan on attending. That's the probability of not attending given that you are a junior. And so from there, we are going to be looking at, I'm trying to find a different color here to use, not attending given that you are a junior. So that will give us a total of 37 out of 114. And lastly, we have find the probability that a student surveyed plans on attending the concert. So there's not really a condition here. This is your typical probability of attending. And so you're just looking at the total, your marginals actually, 119 plan on attending out of the total number of students that were surveyed. Okay, so that's how you can use a table and those marginal frequencies and adjoint frequencies to do your conditional probability. But remember, we also looked at in the last section this relationship. This was based on the relationship when we had A and B being dependent. So it's very similar with your conditional probability. All we've done now is isolate the probability of B given we know that A occurred. So at a school, 60% of students buy a school lunch. That is going to be our event A. Of those students, 10% buy both lunch and dessert. So this would represent A and B happening. What we want to know is the probability that a student who buys lunch also buys dessert. So this is the probability that you're going to buy dessert given we know you already bought lunch. And so that's going to be the probability that you did both divided by the probability of having bought lunch, because we're looking at a subset, the condition that you bought lunch. So this is going to be 0.1 divided by 0.6, which gives you, I believe, when we do it out on our calculator, 0.16 repeating, which is about 17%. Okay, so I realize if you read the section, they also go into something called joint marginal frequencies, relative frequencies. We're not going to be going there. We just really want to use the two-way table as a guide to organize the information.